The Limit of a Function by Maggie Tran. So, what is a limit? Limit as x approaches c, f of x equals L. The formal definition is, if f of x becomes arbitrarily close to a single number L as x approaches c from either side, the limit of f of x as x approaches c is L. So, let's try an example. Given f of x equals 2x minus 3, find the limit as x approaches 4. We're going to solve this by drawing a graph. And we can see when x equals 4, f of x equals 5. Or we can direct substitute this. 2 times 4 minus 3, which we get the same thing, f of x equals 5. There are 3 different types of limits. A real number, L, infinity or negative infinity, or does not exist, or we can notate this as DNE. So we have limit as x approaches c from the right, f of x equals L. This is your right-hand limit, and limit as x approaches c from the left, f of x equals L. This is your left-hand limit. Usually the positive sign is from the right and negative sign is from the left. So let's try some examples by looking at a graph. Here we have limit x approaches 2, x approaches 6, and x approaches 11 from the left, but I forgot my negative sign, and x approaches 6 from the right. So, the first one, my arrows indicate that they both meet from the left and the right at 5. So, limit as x approaches 2 equals 5. So, let's jump to the last one. Limit as x approaches 6 from the right. My arrow indicates that from the right, it approaches 7. So, the second one, limit as x approaches 6. So, we know that from the right, it equals 7, and from the left, we see that it equals 5. So 7 and 5 do not equal, so the limit does not exist. The third one, limit as x approaches 11, we see that from the left it equals 1. So now we have limit as x approaches 0 of x squared. We have two cases, x squared and negative x squared. This is the right hand side and left hand side, where x is greater than 0 and x is less than 0. So from the right hand side we have 0 and the left hand side we have 0. So they both equal 0, so the limit exists. Infinite limits. Limit as x approaches c equals positive or negative infinity. But we have to remember that infinity is not a real number, so technically the answer does not exist. This is a very common mistake that people make. So here's a graph to show an example. Limit as x approaches 0 of f of x. From the right and the left, they both approach infinity, but we have to remember infinity is not a real number, so technically the limit does not exist. This is a very common mistake. How to solve limits? We can direct substitute, multiply by the conjugate, find the least common denominator, factor, or substitute by using trig identities. We use direct substitution when it's a number over a number, and the rest when it's an indeterminate limit, like 0 over 0. Let's try some examples. X squared minus 9 over x minus 3 as limit approaches 3. By looking at this function, we can factor the numerator. So we have x minus 3 times x plus 3 over x minus 3. The x minus 3's cancel out, and we're left with limit as x approaches 3, x plus 3. We can direct substitute and we get 6. So limit of x approaches 3 equals 6. So let's try another example. 4 minus square root of x over 16x minus x squared of limit as x approaches 16. In the numerator we have a square root, so we can multiply by its conjugate. We can multiply the top and bottom by 4 plus square root of x. Then we have 16 minus square root of x over 16x minus x squared times 4 plus x squared. Then we can factor out an x in the denominator, and then the 16 minus x cancels out. As we further simplify, we get 1 over x times 4 plus square root of x. Then we can direct substitute in the 16, and our answer is limit as x approaches 16 of f of x equals 1 over 128. Let's try another one. Limit as x approaches negative 4 of 1/4 plus 1 over x, all over 4 plus x. Looking at the numerator, we can multiply both sides by the least common denominator. So we can multiply both sides by the least common denominator, and then we simplify. Then we simplify it to 4 plus x over 4x, all over 4 plus x. Then we can multiply it by 1 over 4 plus x. The 4 plus x cancels out. Then we have to put the 4 plus x in the denominator of the numerator. Then we can further simplify. The 4 plus x's cancel out, and then we're left with 1 over 4 times x. We can direct substitute in the negative 4, and then our answer is 1 over 16. A common mistake that people make is that they forget to put a 4 plus x in the denominator of the numerator. So now we have limit x approaches to absolute value x minus 2 over x minus 2. We have two cases, x minus 2 where x is greater than 2 and negative of x minus 2 where x is less than 2. Then this brings us to x minus 2 over x minus 2, where x approaches 2 from the right, and negative x minus 2 over x minus 2, where x approaches 2 from the left. Now we have 1, where x is greater than 2, and negative 1, where x is less than 2. And then we have this 1 and negative 1 from the two cases, and 1 and negative 1 does not equal, so the limit does not exist. One last one. Limit as x approaches 3 of 5x over x minus 3 squared. So our left-hand side is 5 minus x over x minus 3 squared. Since there's no method to really simplify, we have to plug in values closest to 3 from the left. So we have 5 minus 2.99 over 2.99 minus 3 squared. And if we simplify that, we get a positive number over a positive number, so it would equal positive infinity. So for our right-hand side, we have 5 minus x over x minus 3 squared, same as the other, but this time we have to plug in values closest to 3 from the right side. So we have to plug in 3.01. So now we're left with 5 minus 3.01 over 3.01 minus 3 squared. Then we get a positive number over a positive number, which is positive infinity. So the right-hand side and the left-hand side agree, so our limit is infinity. Thank you for watching. I hope this video was helpful to you.